What's the first thing you think about when I say the word bioengineering? Maybe you think about science fiction, like those test tube dinosaurs from Jurassic Park. Or maybe you're reminded of pop culture. Anyone take those DNA tests that's supposed to tell you where all your ancestors from? Maybe some of us. Soylent, anyone? If you're anything like I was just a couple years ago, you probably hear the word bioengineering and you think, I have no idea what that means. And probably you're not that worried about it. I mean, it really sounds like something, unless you're a medical doctor, it's probably not going to impact your life very much in the day-to-day. But today I hope to change your mind by sharing with you some of the research that convinced me that we all need to start thinking about bioengineering in a different way, and soon. First, I'll explain a little bit about what it is. So at its core, bioengineering is just like any other kind of engineering. You build stuff, like you would build a road or a bridge, except you might use cells instead of bricks or DNA instead of blueprints. That's because bioengineers build things that are alive, biological. They look at the genetic instructions of every living thing, and bioengineers see a very special coding language, the code of life. And for a long time, all we could do was make very tiny incremental changes to this code. But this field is undergoing a dramatic transformation. Maybe some of you have even heard in the news about the technology that's making this possible, the CRISPR-Cas9 gene editing system. With CRISPR, you can basically change a small segment of DNA just like you can change a typo in an email. It's that easy. It's almost as if overnight, bioengineers went from building small sand castles to being able to build entire cities. It's pretty dramatic. Now, I should let you know at this point, I'm not a bioengineer. I'm actually a research scientist, and I spend all my time thinking about how humans grow and develop, how young children learn. So you might be wondering what that has to do with bioengineering. Well, I'll let you know that because of the power of CRISPR technology that exists now, children entering first grade today have probably already encountered bioengineered projects in their daily life, from the medicines that they take at the doctor to the foods that they eat in their school lunch. But they won't learn about it until college or later, if ever. And that's a missed opportunity. Research shows that starting at age 9, girls and minorities begin to lose interest in science, technology, engineering, and math, STEM, if you've heard that acronym before, because they learn harmful stereotypes about who is able to participate in those fields. And hint, it's not girls or minorities. It's especially tragic because when they're this age, between 5 to 8 years old, they actually perform as well or better than boys in their classroom. Think of what our society could stand to gain if these girls grew up to become contributing adult members of their scientific community. Unfortunately, that's just statistically not a very likely possibility for them. But there is a silver lining. Research also shows that if we can catch children early enough, capture their imaginations in these fields before they learn these harmful stereotypes, that we can sustain their interest through their school years and even into adulthood. It sounds pretty great, right? I think that bioengineering is one of the best ways that we have to do that. It combines some of the best elements of 3 different already familiar STEM fields. You have the creativity and the flexibility of engineering, the creative problem solving of computer science, and the observation and experimentation of life science. What's really exciting to me about bioengineering is the real-world relevance that it also offers. And we know that young children as young as 4 can become coders, builders, and experimenters. But the real-world relevance is a very exciting learning opportunity to offer young children. They can wrestle with the same kinds of unresolved issues, unanswered questions that professional-level scientists are still scratching their heads over. And that's a beautiful thing to be able to offer a young child in terms of a learning experience. But more importantly, kindergartners today are going to inherit these unresolved questions anyway, in 2 decades, when they are of voting age. We need to prepare children now to make the tough decisions that are going to face them when they are adults in the future. But how can we teach such big ideas to such small children? In my graduate work at Tufts University, I work in the DevTech Research Lab, where we spend all of our time thinking about how we can design, implement, and evaluate new technologies to introduce young children to the topics of the 21st century. We make tangible tools so that children can wrap their hands and their minds around these new ideas. We knew we wanted to make a suite of tools to teach about bioengineering. So we teamed up with the Human-Computer Interaction Lab at Wellesley College, all-female team, and we designed Crispee. Crispee is a cute play on CRISPR that we're all now familiar with. And essentially, we made a little background storybook to give you a context of a firefly named Bob, whose light we can program to change color, to glow in different colors, depending on the gene sequence that we code it with using Crispee. And you can also program him to change different color lights depending on his environment. And we, of course, made stuffed animal versions of Bob and some of his other glowing friends to sort of capture children's curiosity. And it sounds a little abstract hearing me just talk about it, so instead of telling you more about Crispee, I'm going to introduce you to a bioengineer who can show you how it works. This is Priya. Priya's 5 years old, and she's a first-generation immigrant. Right here, she is building a sequence to make a purple light in her fish. She was really, really excited about making a purple glowing fish. She's testing her program to make sure that the sequence makes sense to Crispee, and now you see her physically mixing it. That actually simulates something that happens in the actual CRISPR system, a centrifuge. It's almost like taking your code and putting it back into the animal's genome. Now she's testing her program, and voila, she made a purple light. You can see she's really, really proud of that light. Actually, Priya was so proud of this light that she continued to build and work on this fish idea of hers. She added special genes so that when her fish swam in dirty water, the light would change color to green. And when I asked her why she would make that kind of a program, she explained to me, 5 years old, that she wanted to make something so that when scientists or humans were looking at the water and they see where the fish is going and when it turns green, they'll be able to know that's polluted, and that's where we should start to clean up so that we can clean this habitat. I thought that was actually a very clever solution from a kindergartner to an environmental problem. You might not be surprised from that story, but Priya was extremely clever throughout all of our testing. We gave her little sample tests to see how she was going to respond to science and engineering answers, and she was always very good at the questions we asked her, and every time she would ask us if she got the answer right. And I didn't say, I just said it's not a competition, but she did almost always get the answers right. So I thought maybe she just had some really strong science and engineering background in her home, but then I learned that she actually was acing some of the bioengineering questions that we gave her, questions we knew she would not have come across. Like this, where we showed her a picture of a sheep and a picture of 3 fish. And we asked her, if bioengineers want to make this sheep glow, which of these fish has the genes that they will need? Does anyone in the audience have a guess? You can shout it out. A. Nice work, everyone. We're all going to learn some bioengineering today. So you're probably not surprised by now, but Priya also got this right on the first try before she ever even played with Crispee. So that tells me I need to work on my assessments a little bit. But for Priya, I found something very interesting in the post-test. So after she played with Crispee, we asked her the same exact question, and again, she got the answer right. She answered A. But this time, there was a very important difference. She did not ask me if she got the answer right. Instead, she asked me this. Why do scientists want to make the sheep glow? Why do we need a bioengineered sheep? To me, this answer is the most important question of our entire study. Maybe one that we're all wondering now, right? So to me, this says Priya's ready to think about something more important than just the mechanics of how bioengineering happens. She's ready to wrestle with the ethical justification of engineering genes. And she's not the only child in our study to reach this kind of a conclusion after playing with Crispee, which I think is very heartening. In 2015, in a different TED Talk, Dr. Jennifer Doudna stood before the world and she implored the scientific community to pause and consider the ethical implications of a tool that allows us to change our own DNA, a tool that she herself invented, the CRISPR technology. Already, CRISPR is a global sensation, and everyone from government to industry wants a piece of the action. And it's easy to see why. With CRISPR, we can help same-sex parents have their own biological children. We can bring extinct animals back to life. And we can even cure terminal illnesses like cancer. It's not an overstatement to say we are living in a genetic revolution. It's an amazing time to be alive. But I do wonder if we're exercising the caution that Dr. Doudna recommended. Like I said, I'm not a bioengineer, and I don't make the choices about whose genes we edit and why. But I hope that the leaders who do make those choices are asking the same questions that 5-year-old Priya is now asking, and justifying the ethicality of their work. When I walk into a classroom of young children, I see the future leaders of tomorrow. I want to honor that future by making tools to help young children wrestle with the same questions that real leaders will need to ask. Crispee is a great tool to teach about cutting-edge technology, But it's also helped these children think about consequences and trade-offs of their designs, to hear each other, listen to dissenting opinions, and recognize different perspectives, and to really practice solving problems using science and technology. This genetic revolution is more than just a bunch of fancy new machines, and the stakes are too high to ignore the girls and the minorities who might become the change makers of tomorrow. So for the young people listening in the audience today, I actually have a message directly for you. You are the future revolutionaries of this gene revolution, and I can't wait to see the world that you create. Thank you.